Well, thank you, Alan, for a wonderful presentation, and Alan for a nice introduction as well. So basically, I'm not sure if you have heard of Cummins and Voortman, but we are a very young practice set up at the end of 2005. And the way I'm going to structure this presentation is I'm going to give a very brief overview of our company, and then I'm going to go through architectural case studies, followed by urban design case studies. After which, I'm going to have some general findings. So even if you have any questions during the presentation, feel free to stop me and I'll try to answer you as best as I can. So we set up a practice. We are both architects, actually, Robert Cummins and myself. I'm in Ireland since 1998, and we decided in the late 2005 to set up a practice. And we're based both in Tipperary and in Dublin. We're specialized in sustainable architecture and urban design. And as you can see, we have private domestic clients, which is the majority of our projects. We have commercial and we have public sector, which is mostly urban design projects. And we think that we are technology-led. We think it's quite important, the tool we use, to be as efficient and as productive as possible. So this brings me to the next slide. It's briefly to highlight the tool, the very importance of the tool. As in any profession, the choice of the tool is critical. And we believe that there are three key elements and components that forms that tool. You have the user, the software, and the hardware. We ourselves, we're using ArchiCAD 12. We're not yet up to speed with 13 and 14, unfortunately. We will move to that very soon. And we're using very high-powered Apple computers. So we feel that it's a very good combination, and it forms like a wheel of three elements. And imagine if there is one element, like if you have a lack of ability, or if you don't have enough processing power, the wheel might not turn as fast as it could. So it's really, we're talking about efficiency, and every single element is important. It's a slightly bigger project. It's actually in a small village called Hospital, and we had to assess all the past permissions and then provide a planning permission for a residential area, a commercial area, and the first leg of a bypass. So these are 3 or 4 designs that were already done by another company. And we just did a 3D model just based on their drawing. We didn't have any kind of information in relation to the contours and all the rest. And it's just the past planning didn't succeed completely. So we were asked actually to take it from here and produce a design based on the new requirements from the planning authority. And the very first thing we did was actually to analyze the site in detail in relation to the contours and the site constraints. You can see from this survey that from one point to the other point of the site, you can have a height difference of almost 10 to 15 meters, which is very, very difficult actually to integrate a design into. So that's why, you can see, we have built actually. First of all, let me say as well, the very first thing we did was to build a 3D mesh of the existing site, and then when we could just generate all the automatic sections, because it just comes automatically, we could assess what type of buildings would be appropriate for the site itself. So you can see the roads that turns around because of the site constraints. You can see on the one side the residential part, you see the bypass, the first leg of the bypass, and the commercial side on the opposite side. This is a real representation of the whole model. So one of the benefits of creating a virtual model, is that you have to actually resolve every single square meter within the scheme. So there was no kind of a unresolved area, especially in this site where it's quite important that all the height differences were actually taken into account. You might say, well, it takes an awful lot of time, especially at planning stage, to get this right. But in the end, because we have the power of sections and elevations that are automatically generated, we save quite a bit of time in the long term. So this is just an example. We had generated, I think, 10 or 20 sections we could generate as many as we wanted, really, to make our case. And it's very good, like, for conflict detection as well. Whenever we generate a section, it comes up, and you can see here that was the first design with apartments building that was later omitted. There's too high density, but you can clearly see that you see all the height lines, the trees, the buildings, and if there is anything wrong, you can go back to the main model, modify it, and it will update itself automatically on all your sections and your sheets. Creativity. So the findings, well, as you can see, it really improves the design process dramatically. It allows for an immersive design. You can alter the design in 3D quite easily. You have an early conflict detection, and therefore you have an improved quality control. And that means as well that it limits the need for repetitive drafting, like all the elevations and sections are generated automatically. And as I said earlier, of course, the accuracy of the model depends on the accuracy of the survey. And the accuracy of the final projects will depend on the accuracy of the model. So the better model you have, the more time you spend building a 3D model, the better it is in the end. So as I mentioned before, we have a production process that is very streamlined. You have information flow. Like once we change the model, everything else is updated automatically, like all the kind of window schedules, all the kind of plans, sections, and elevations. And of course, an accurate model benefits the project in terms of greater precision. You have less room for error, meaning less variations during the construction process, and also like improved cost control and project time frame. And in the end, it's also, of course, a very effective communication tool that allows the client to see the full benefits and sometimes the complexity that cannot be rendered into the, to the client and to the whole project. And the final thought really is actually we analyze our sites, all our sites in 3D, as you have seen. We design in 3D, we modify in 3D, and there is a potential to communicate in 3D. We live in a 3D world, so I mean, it is only normal that we always think in 3D anyway. To design in 2D was always a step back, we felt. So it's only natural to come back to the 3D world. So this BIM software, it contributes to the construction process in terms of we have less project variations, we have improved cost control, and it benefits dramatically as well the time frame. That means greater efficiency, and also we can be more competitive. As a final word, I'd like to cite this citation from John Ruskin, who says, like, the measure of any great civilization is in its cities, and the measure of a city's greatness is to be found in the quality of its public spaces, its parks, and its squares. And we'd like to add that in order to create successful public spaces, we need the most powerful and most comprehensive tool available on the market to make this happen. And we believe the virtual building model provide us with that tool. So thank you for your attention, and if you have any questions, please let me know.
Thanks,